Dropping from a height will cause an object to gain kinetic energy. A diver, for example, gains kinetic energy despite seemingly having no input energy store, so it's as if the kinetic energy comes from nothing. This is because the object has gravitational potential energy. So the energy store is gravitational potential energy, which the person had on the cliff before they jumped off. Remember that Ke is kinetic energy and GPE is gravitational potential energy. So gravity is doing work to convert the gravitational potential energy to kinetic energy. But what exactly is gravitational potential energy? Well, gravitational potential energy is the energy held by an object raised above ground level. This can also more generally be defined as the energy held by an object within a gravitational field. So GPE is equal to the mass multiplied by the gravitational field strength multiplied by the height of the object. The gravitational field strength is the gravitational force that acts on a mass, so it determines the size of the weight force. This equation only applies at the surface of a planet where the gravitational field strength is constant, and it can be derived by substituting the equation for weight into the equation for work. In symbol form, it is EP is equal to m times g times h. The mass is measured in kilograms, the height is measured in meters, the gravitational field strength is measured in meters per second squared, which on the Earth's surface is 9.8. The gravitational potential energy is then measured in joules. This equation will be given to you in an exam, and you can assume it's the correct equation to use for any GPE-related questions. It's an extremely important equation, and you should be very familiar with it. So let's have a look at an example. A 3-kilogram eagle flies at a high altitude with 100 kilojoules of gravitational potential energy before diving towards its prey on the ground. Calculate the height the eagle flies at before it dives to two significant figures. So we can round our answers to a certain number of digits, and the number of significant figures are the number of digits in the value. So for step 1, let's write down the key information and check the units. The mass is equal to 3 kilograms. The gravitational potential energy is equal to 100 kilojoules, which is 100,000 joules. The field strength is 9.8 meters per second squared, and we want to calculate the height. For step 2, let's rearrange the gravitational potential energy equation to make height the subject. We can't use a formula triangle to rearrange this equation, but we can do it algebraically. So we can divide both sides by mass and field strength at once, and this is because the height is being multiplied by both of them. So the equation becomes GPE divided by mass multiplied by field strength is equal to the height. For step 3, let's substitute the values to find the height. And here we've simply flipped the equation we found on the previous slide. So the height is equal to 100,000 joules divided by 3 kilograms multiplied by 9.8 meters per second squared to give us 3,401.36 meters. For the final step, we need to round the height to two significant figures. So the first significant figure is 3, the second is 4, and the next digit is 0, so we can leave the last significant figure to give us 3,400 meters.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!